Okay, so we have already started with hydrocarbons, and we did the structures of hydrocarbon and also the isomerism. That was our last part, which we had studied in our last lecture. So today we will be doing the reactions of alkanes. Okay, we'll be doing about for the reactions of alkanes. The first reaction of alkanes is combustion of alkanes. The first reaction of alkanes is combustion of alkanes. Now, combustion of alkanes is where there are two parts. Number one, complete combustion. Okay, complete combustion, which is nothing but it is reacting of an alkane with excess oxygen. Okay, example, let's say I have methane, CH4 plus O2. Whenever it's a complete combustion, remember the product will always be carbon dioxide and H2O. So CH4 plus O2 gives CO2 plus H2O. That's my complete combustion reaction. And definitely we need to balance it. So for balancing, there will be a priority. We will first balance carbon, then we will balance hydrogen, and then last oxygen. So for balancing, carbon on the left hand side is one atom, carbon on right hand side is one atom. Hydrogen, there are four. Hydrogen over here, there are two. So we put it two to make balance. And oxygen, if we talk about 2 plus 2, which is 4, and this will be 2O2. So this is how my complete combustion is. Suppose let's say I want to do complete combustion for ethane. So ethane is C2H6 plus O2 gives CO2 plus H2O. Can anybody balance this equation? C2H6 plus O2 gives CO2 plus H2. What will be the balancing? C2H6 plus O2 gives CO2 plus H2O. Yes, Manas, balancing.
So it will be 2 CO2.
Okay, so first we'll write carbons. There are two, so 2 CO2. Okay.
So we'll have 4 oxygens on the side and 2 oxygen on the other side, and plus the 1 oxygen molecule from.
Okay, now, okay, so remember over here, as I told you that you have to set a priority. The reason we cannot balance the oxygen over here first, before that we need to balance hydrogen. If we balance oxygen first, then it will not be a correct way. So the order of priority, that's the note point which I would like to give you, that for balancing hydrocarbons, okay, for balancing hydrocarbon equations, the order of priority will be carbon, hydrogen, and oxygen. So now over here, see two carbons are there. So we have written 2 carbon. Hydrogen, there are 6. So we are going to write 3 hydrogens. So 3 into 2, 6. Then talking about oxygen, 2 2s are 4. 4 plus 3 is 7. There are 7 oxygens, and over here the oxygens are 2. Correct? Now, if I want to make 7 oxygens, so now one way is I can just put 7 by 2 or 3.5 to make it 7. Okay, this is one way. Or what I can do is, I will double the whole equation. Means to remove the fraction, 7 by 2 is a fraction or 3.5 is a decimal. So instead of decimal, what I can do, I can multiply the whole equation with 2. So what I will get, so I will write the equation once again, C2H6 plus CO2 plus H2O. So I'm going to write, I'm going to double the whole equation, means multiply it with 2. So this becomes 2. 7 by 2 into 2. 7 by 2 into 2 is 7. 2 into 2 becomes 4 and 3 into 2 becomes 6. So this is my balancing equation. So I'm repeating once again, whenever you want to balance hydrocarbon, the order of balancing carbon, hydrogen and oxygen. Use pencil for balancing because it's always a trial error method. Don't use pen. Okay, if you are not balancing the equation, you are going to lose marks. So don't use pen, first use pencil. Once you are confirmed with the balancing, then rewrite with pen. Don't leave it with pencil, otherwise it will be recognized as, you know, rough work. It will not be counted. So I told you that you can leave your balancing equation in two ways. Either you can put it in fraction, or you can just write down as like you can make it in a fraction and then you can put it into whole number. So this is about my complete combustion. Remember, in complete combustion, the oxygen used is in excess, and that's why the product formed is carbon dioxide and water. Immaterial, it's water vapor actually, because it's highly exothermic reaction. Lots and lots of heat energy is given out. So remember, any hydrocarbon, it can be a 10 carbon hydrocarbon or it can be octane, nonane, anything, always the product will be carbon dioxide and water vapor for complete combustion. Moving on to the next one, that is second one, incomplete combustion. Okay, incomplete combustion. Now, incomplete combustion is nothing but it's a combustion, that is, it's a reaction in oxygen, but instead of excess oxygen, over here there is limited oxygen, limited O2, means oxygen which is present is in less quantity. So always the product will be carbon monoxide and H2O. So the difference is in the product, formation of product, and the difference is also of the releasing of heat energy. In complete combustion, the heat energy evolved is going to be much higher, whereas in incomplete combustion or partial combustion, the release of heat energy is going to be less. So let's take an example. Example, once again, we'll take methane CH4 plus O2. It's limited. So the product will be carbon monoxide plus water vapor. Once again, let's balance the equation. CH4, carbon 1. So carbon is balanced. Hydrogen 4, hydrogen 2. So it's going to be 2H2O. Then let's go for oxygen. Now oxygen over here is 1 plus 2. 3, and over here it is 2, so we can write 3 by 2 or 1.5. Or what is another way? CH4 plus O2 gives carbon monoxide plus H2O. I know that the previous reaction has 3 by 2, which means it's in a fraction. So I will multiply the whole equation, this whole equation with 2. So what I'm going to get? 2CH4, 3 by 2 into 2 will be 3O2, giving me 2CO plus 4H2O. Okay. Please solve this question. C3H8 plus O2 gives carbon monoxide plus H2O. I'm going to wait for 2 minutes, write the equation and balance it. Okay. Now, how many carbons are there? There are 3 carbons. 3 carbons we know that, okay, we'll write 3CO, 8 hydrogens, which means 4 2s are 8, 8 hydrogens. Now, oxygen over here, it is 2, and over here, 3 plus 4, which is 7. If I want to make 7, so I have to write either 3.5 or just make one simple rule between 2 and 7, which is the larger number 7. So just put 7 by 2. Even here also, oxygen was 2 in the previous example, and right hand side, oxygen was 3. So what we did, higher number divided by 2. So 3 by 2. So over here also, if it is 3 plus 4, which is 7, which means it will be 7 by 2. Now, or what I can do is, if I don't want my reaction in fractions, I want it in my in whole number. So I will rewrite this equation by multiplying with 2 so that that fraction part gets eliminated. The fraction part I don't want. So it will be eliminated by multiplying it with 2. So my final answer is C3H8 plus O2 gives CO plus H2O. So this is 2, then 7, 6, and 8. So Jessica, Akbar, are you understanding? For those who have not yet written the answers in the chat box, is it clear now how to balance the equation? So whether it's any hydrocarbon or any other balancing equations, make sure that you are balancing first carbon, hydrogen, and oxygen. If there is a metal, let's say suppose if there is an equation, I'm not talking about the hydrocarbons, but let's say any equations of acids, bases, and salts. If there is a metal, then you will first balance metal, then non-metal, then carbon, hydrogen, and oxygen. So this is always the hierarchy of balancing. The reason is because when you follow these hierarchy, the hierarchy which I told, the priority list, it is always better, or you can say the maximum probability, so that your balancing will happen. If you do not balance the equation, then definitely you are going to lose marks. Okay. Okay, so this was about the second equation or reaction, which is incomplete combustion. So first was complete combustion, second was incomplete combustion. Moving ahead with the second type of reaction. Combustion was one type, which was divided into two parts, complete and incomplete. Moving on to the second reaction, that is type of reaction, which is substitution. Okay, substitution reaction. Now, substitution reaction is a characteristic of alkanes. It can always take place only in alkanes, saturated hydrocarbons. So what is substitution reaction? So substitution reaction, the general equation is, if I have any alkane plus it is going to react with chlorine gas, very important, the condition is UV light, or you can also write sunlight. The condition will be UV light or sunlight, and the product you will get will be chloroalkane plus HCl, that's hydrogen chloride. So let's take an example. If I have methane is what? CH4 plus Cl2, chlorine gas. Now this chlorine is Cl bond Cl, means the chlorine molecule has one covalent bond. Now what is a substitution means? A normal meaning of substitution. Normal meaning of substitution means one of the things from alkane is going to replace, there will be a replacement. It's been substituted. So any one hydrogen out of this 4, it can be any one hydrogen which can be replaced by chlorine. So one hydrogen will be replaced by chlorine, and that hydrogen will go with another chlorine to form HCl. So the bond between Cl will break. One Cl will attach to the carbon atom. So that's how the substitution is taking place. So this is methane. So the name of this is chloroalkane. So this will be chloro, and the name of the compound will be chloromethane. or it can also be called as methyl chloride, because remember CH3 group. Yes, all of them have same kinds of bonds over here because all are hydrogen, na? CH, CH, CH. So all hydrogens are same. So you can replace any hydrogen. You can replace this hydrogen, this or this. Anything is fine. So this you can also write it as CH4 plus Cl2 gives CH3Cl plus HCl and UV light, UV or sunlight. I normally prefer this type of reaction, means where I can show the displayed bonds. Reason is because for me it is understanding that okay, where the bond is breaking. So sometimes they can ask you to write the displayed formula also, or sometimes you, if you're comfortable writing this in a condensed form, you can write it in that way as well. That's fine. Please copy down this reaction, which is substitution, because organic, I want you to write the reaction. So copy this and then we shall go with the next part. Alkane. There is one more reaction of alkane, the third one, which is called as cracking. Cracking of alkanes. Okay, now cracking of alkane means you have alkane, which is a larger hydrocarbon. Okay, before doing this, alkane which will break. So crack means it will break into two parts. One will be alkane and one will be alkene. Now, what do I mean by this? Now, let's say you have alkane, which is a very large molecule, which will break into two parts, alkane plus alkene, where alkane will again be a large molecule and alkene will be a small chain, large chain. And the catalyst used over here is either silica or Al2O3, that's aluminium oxide. 300 degrees Celsius is the temperature. Now, what do I mean by this? Let's take an example. Alkane, I'm taking C10H22. This is decane. Al2O3 and 300 degrees Celsius. Now, there can be various possibilities of this C10H22 to break. Number one possibility, now there are 10 carbon atoms. So there can be possibility of one molecule will have 8 carbon atoms, another molecule will have 2 carbon atoms. So 8 plus 2, the breaking can be 8 plus 2, one possibility. Now, as I told you that there will be two products, one big product and one small product. So the big product means the one which is having more number of carbon atoms will be my alkane. And what is the general formula of alkane? We know that alkane follows CnH2n plus 2 and alkene follows the formula CnH2n. So 8 into 2, 16, 16 plus 2, 18, and this will be C2H4. So you are not eliminating any carbon, neither any hydrogen. If you add both of them, you will get this. But it's only the way you are breaking it. Let's say you have 10 carbon atoms. So 10 carbon atoms, how will you break? You cannot break 9 plus 1 because there is no alkene with one carbon atom. So it can be 8 plus 2. What will be my another possibility? C7 plus C3. What will be the formula of alkane with C7? Formula of alkane with C7. Vanya?
It will be C7H 14 plus 2.
Yes. So 14 plus 2, which is 16. So C7H16 and my alkene will be C3H6. So this can also be one possibility. Okay. Then another possibility, C6 plus C4. So Jessica, can you tell me what will be the formula of alkane with C6?
I'm not sure.
Okay, now there are 6 carbon. Can you substitute the values of H over here? What will be, how many hydrogens will be there? If there are 6 carbons, I told you that number of hydrogens will be, you have to double plus 2. So what will be the number of hydrogens, Jessica? If N is equal to 6, so what is double of 6?
It would be 12 plus 2, which would be 14.
14. Very good. And what will be the formula of alkene with C4? Alkene is CnH2n, means hydrogen will only just be double.
So it would be H8.
Very good. Okay. Then C5 plus C5 is not possible. C4 plus C6 is not possible, which means you cannot make alkene which is a more carbon atom. So the possibility is only this 3. Any one possibility. Okay, any one possibility. Also, for alkane, there is the cracking, there is one more where you can make alkene plus hydrogen. There can also be one more where you can have C10H20 plus H2. But majority times this is what is expected. This is majority or major possible product. So I repeat once again, total there are 3 types of reaction: substitution, combustion, and cracking. Combustion will be of 2 types, complete and incomplete. Complete combustion will give you CO2 plus H2O. Incomplete will give you carbon monoxide plus H2O. Substitution will give you chloroalkane plus HCl, and cracking will, you have a bigger hydrocarbon which will break into 2 parts, one a large alkane and one a small alkene. Please copy down this, take 2 to 3 minutes, copy down the equation. Okay, so the second part of hydrocarbons is alkenes. Now alkenes are my unsaturated hydrocarbon. Unsaturated hydrocarbon with general formula as CnH2n, where N is my number of carbon atoms. The first member of alkene is not methane, but it is ethene. The first member of alkene is ethene. So starting with the structure, example number 1, where N is equal to 2, so C2H4. Now, since it's unsaturated hydrocarbon, and what is the peculiarity of alkene? It will have carbon to carbon double bond. So C double bond C. Now, carbon to carbon double bond is already there. How many more bonds should be there for each carbon? Huma, can you tell me how many more bonds will be there for each carbon?
Miss, could you repeat, please?
Each carbon should have how many bonds? What's the valency of carbon? The valency. How many bonds are expected in carbon atoms?
Is it 12?
No, the valency is 4. Now remember CH4, so there should be 4 bonds, right?
Yeah.
Now already 2 bonds are there. So how many more bonds should be there for each carbon?
2 more each.
2 more each, right? Because total there should be 4 bonds, and that is how this is your structure. You can write, you can put hydrogen over here also. It's not. I mean that's allowed. So wherever you can put right side, left side, anything is fine. So this is my structure of ethene, C2H4 ethene. Let's go for the next one where N is equal to 3. C3H6, which is propene. So 3 carbons, so 1, 2, and 3. And now it has carbon to carbon double bond. So carbon to carbon double bond, that doesn't mean that between each carbon atoms or between 2 carbon atoms, every time there will be double bond. It's not like this that both the carbons will have double bond. It is either side. Means either you put double bond between first and second, or you put double bond between that from that side first and second. Anything is fine for writing the propene. I repeat, for alkene, depending on number of carbon atoms, between any 2 carbon atom, there has to be double bond. That doesn't mean that for between every carbons, there has to be double bond. That is not alkene. For every carbon, no double bond. Between any 2 carbon, there has to be double bond. So when we talk about propene, now propene has 2 possibilities. Either to put double bond over here or to put double bond over here. It is your choice. Either you can put double bond between first and second carbon from left hand side, or you put double bond from the right hand side, counting that carbon as first. And then writing, since it is having 2 bonds already, so 2 hydrogens. This carbon already has 3 bonds, 1, 2, and 3. So only 1 hydrogen, and the last carbon will have 3 more bonds, so 3 hydrogen. This counts as C3H1, 2, 3, 4, 5, and 6. Similarly, on the next molecule, this will have 3 hydrogens. This has 3 bonds, so 1 hydrogen, and this will have 2 hydrogens. So please copy down the structure of ethene and propene, and I'll be back in. So there will be 4 carbon atoms, 1, 2, 3, 4. I am putting double bond over here. Okay, I'm putting double bond over here. Just 1 second.